You probably remember that we had 5 different ways to show that triangles are congruent. These are the 5 congruent shortcuts that we used. To use them, we just had to show that these corresponding parts of the triangles were congruent. For triangle similarity, we only have 3 shortcuts to worry about. The A still means that we're looking for congruent angles. However, the S doesn't represent congruent sides. It means that our sides will be proportional. Let's take a look. Here's the side-side-side triangle similarity theorem. It says that if the corresponding sides of 2 triangles are proportional, then the triangles are similar. So if we could say that AC over DF is equal to AB over DE, and that's equal to BC over EF, then we could say that these triangles are similar because all of their pairs of corresponding sides are proportional. Well, we have some measurements for our triangles here. Let me substitute them into these equations. And substituting the values for the side lengths into these equations, this is what I get. And that simplifies to 2 equals 2 equals 2, which is true. So these 2 triangles are similar, and I can tell because all of their corresponding sides are proportional. Let me change the values of my side lengths just to do a more concrete example here. Earlier, I had the expressions 2x, 2y, 2z, and x, y, and z for my side lengths. Now I've added in some actual units. So I could write these proportions to describe the relationships between the side lengths. And this proportion would be true because each of these ratios is equal to 10. 10 equals 10 equals 10. So the triangles are similar. Now let's look at side angle side triangle similarity. This theorem also uses proportional sides. It says if 2 sides of one triangle are proportional to 2 sides of another, and their included angles are congruent, then the triangles are similar. So the easy thing to tell looking at these 2 triangles is that they have some included angles that are congruent. Now, in order for these triangles to be similar, it must also be true that the corresponding sides on either side of that included angle are proportional to each other. So let's write a proportion and see if it's true. Here we have 3x over x equals 3y over y. That simplifies to 3 equals 3. Woohoo! That's true. So that means that I have 2 sides that are proportional to 2 sides of the other triangle. The included angles are congruent, so I could say by side angle side triangle similarity that these triangles are congruent. And this is how this problem might look if I had numbers instead of expressions for my side lengths. Here I can write that 12 over 4 is equal to 9 over 3, and that's true because 12 over 4 equals 3 and 9 over 3 equals 3. So those ratios are equal and the proportion is true. Finally, we have angle-angle triangle similarity, and this is probably the easiest to use. What we're looking for here is just 2 pairs of congruent angles. If 2 angles of one triangle are congruent to 2 angles of another triangle, then the triangles are similar. So here I can see that angle C is congruent to angle F, and I can see that angle B is congruent to angle E. And that's all I need to conclude that the triangles are similar to each other. So that's how you use angle-angle triangle similarity. So let's look at an example. Here I want to know, is triangle ABE similar to triangle ACD? So let's think about what we know about these triangles. Well, first of all, I can see that my triangles share a common angle up here. And that angle is congruent to itself by the reflexive property. So I know I have one congruent angle. So now let me look at my sides. I wonder if they're proportional. I already know that angle A is congruent to itself. So what about the sides that make up angle A? The sides between which angle A is included. Are they proportional? Well, here I've written a proportion showing those relationships, and now I just need to substitute in these numbers to see if that proportion is true. I've substituted in my numbers, and one thing I want to point out is that the denominator in this case represents my larger triangle. It represents the one I've highlighted in blue, and my numerator represents my smaller triangle, like the top part of my candy corn, if you will. And then I've substituted numbers in the numerator and the denominator in the appropriate spots. Okay, so now let's see if this proportion's true. One way to find out would be to cross multiply. You could also simplify both ratios. I'm going to go the simplification route. Doing that gives me 2 over 3 equals 2 over 3. And that's true, so my sides are proportional. So now I can say that these triangles are similar by side, angle, side similarity. So here's another example, and in this example we're told that these two triangles are similar, and our goal is to find the length of side CE. So since I know that the triangles are similar, I know that their sides are proportional. So I'm going to write this proportion. AB over AC is equal to DE over CE. Substituting my values into the proportion, I end up with 12 over 15 equals 8 over x. You can cross multiply and divide, or you can simplify and solve. I chose to divide both 12 and 15 by 3, and that gave me 4 over 5 equals 8 over x. Well, I know 4 times 2 is 8, and I knew 5 times 2 is 10. So that tells me that x is equal to 10. So I can also use similar triangle relationships to solve missing side lengths.